Good morning, students. Today we are going to study about electrical conductivity sigma. So we know that uh, according to Drude's and Lorentz and Drude's theory, when there is no external electric field, the electrons moves in a random manner. So once when an external electric field is applied, all the electrons are moved towards the positive terminal of the battery. So that is the electron flow opposes the flow of the electron current, and the velocity acquired by the electrons are called as the drift velocity. So drift velocity is nothing but the velocity acquired by the electron in an opposite direction of the external field. Okay, so that velocity is called as the drift velocity. So when you are applying an external electric field, so the force experienced by the electron, that force is called as the Lorentz force, which is represented as F is equal to minus EE. From Newton's second law of motion, we know that force is equal to mass into acceleration. Now compare these two equations and find the value of A. So ma is equal to minus EE, where the acceleration is equal to minus EE by m. But from definition, we know that acceleration A is equal to Vd by tau. So the velocity, drift velocity, is represented by Vd, which is equal to A tau. So substitute equation 3 in equation 4. So here we know the value of A. A is equal to minus EE by m. In equation 4, instead of A, we are substituting the value of minus EE by m. So we got an equation for drift velocity, that is Vd is equal to minus EE tau by m. So we know that from definition, current density J is equal to minus NeVd. N number of electrons, E charge of the electron, and drift velocity is represented by Vd. So here, instead of Vd, substitute this equation minus EE tau by m. So minus minus will get cancelled. So we get an equation J is equal to Ne square E divided by tau by m. From we know that the current density is equal to sigma E. So therefore, we want the value of sigma. So we are rewriting this equation. Sigma is equal to J by E. So bring this E to the denominator. So J by E is equal to Ne square tau by m. So from this, we got the value of electrical conductivity. So the electrical conductivity sigma is equal to Ne square tau by m. So N is the number of electrons or number of charge carriers per unit volume. E is the charge of the electron. Tau, the time taken, and m is the mass of the electron. Next, we are going to study about thermal conductivity. So the thermal conductivity is actually represented by the symbol K. So here the amount of heat conducted in a material is equal to Ka dt by dx into T. So thermal conductivity, area of cross section, dt by dx is the temperature gradient and T is the time. So from this we are rearranging the equation and we are getting the value K is equal to Q divided by A dt by dx into T. So here we are taking the area is equal to 1 meter square and T is equal to 1 second. So when you substitute this, you will get K is equal to Q dt by dx, the amount of heat conducted per unit temperature gradient. So Q is equal to K dt by dx. So now we are going to find the thermal conductivity. So here for this, we are taking a cylindrical rod and whose ends are A and B. The distance between the two ends A and B is taken as lambda, and A is the high temperature region and B is the low temperature region. So the temperature at A is denoted as T and the temperature at B is denoted as T minus dt. So obviously we know the heat flows from the high temperature region to low temperature region. So at the junction A, the kinetic energy of the electron is represented by 3 by 2 kT. K is the Boltzmann constant and the temperature T is across the temperature at A. So similarly at B, the kinetic energy of the electron is represented as 3 by 2 K T minus dt. So we have to calculate the excess kinetic energy of the electron. So subtracting equation 1 and 2, we are getting 3 by 2 K dt. This is the excess kinetic energy of the electron. So now we have to calculate the number of electrons crossing from A to B, which is equal to 1 by 6 NV. So therefore, we have to calculate the excess energy carried by the electron from A to B. So since A is the high temperature region, the energy is carried from A to B. So what is the energy, excess energy carried from A to B, which is equal to number of electrons crossing and the excess kinetic energy. When you multiply these two terms, you will get the excess energy. So 1 by 4 NV kdt. So similarly, the energy deficient in the region B to A is equal to, because it is same as the magnitude, but since it is a deficient one, we are putting a negative symbol, minus 1 by 4 NV kdt. So next we have to calculate the net heat energy. So we have to add these two equations 5 and 6. So 1 by 4 NV kdt minus of, sorry, we have to subtract, I told you add. So subtracting these two equations, so minus into minus plus. So when you are adding these two, you will get the net heat energy Q is equal to 1 by 2 NV kdt. So from definition, we know that Q is equal to dt by dx. Here we have taken the length as lambda. So Q is equal to k dt by lambda. So what is the value of Q? Here it is there, half NV k dt, substitute value. So dt will get cancelled, bring this lambda here. So lambda is the mean free path. We know the formula for lambda, that is lambda is equal to V tau. Substitute here. So half NV square k tau is the thermal conductivity of a material. Thank you.